Hey everybody, in today's video we're going to start learning about two-dimensional motion. So there's multiple types of motions, and this is going to be the second type that we learn about. So in one-dimensional motion we covered objects that would end up going either straight to the right or to the left, or they would just go straight down. And that's pretty self-explanatory as to why that would be considered one-dimensional. So you have them either going up or down, or you'd have them going left or right. Now obviously, since they're just going in one direction, and if you construct like an axis or something, you can see that the direction the object is moving in would match with the axes, and that's why it's one-dimensional. But if we move on to two-dimensional motion, we know that objects can go in directions that are not just straight. They can travel in curves, like when you throw a baseball, and they can travel in curves in several different ways as well. So two-dimensional motion is different from one-dimensional motion in the aspect that it has components. So to show you an example, if you throw a baseball, if you're standing right here and you throw a baseball, it's not going to take a straight path. Due to gravity and other forces acting on the ball, we're going to see that the baseball will most likely take a parabolic path, something like that. Now, because of this, the ball has components. So if we were to split this up into components, kind of how we did in one-dimensional motion, and construct an axis around it, our object would have an x and a y component. So if we put this in terms of a triangle to make a couple of equations, now if our object is accelerating at, here, let's flip the triangle here. So it's going the other way. So if our object is accelerating in our upwards direction, it's going to have an y component going like this and an x component going like that. Now if we call this our velocity component, this is going to be our y component of our velocity, and this is going to be the x component of our velocity. So we're going to have an angle that our object is thrown at. And from this we can construct several relationships. First one, we know that the vector is going to be equal to, our velocity vector is going to be equal to the sum of our x and y vector. So we can say that v is equal to v sub x plus v sub y. Now when you're doing this in actual physics problems, keep note that you do not actually add the vectors. This is a right triangle, so you have to use the Pythagorean theorem. So that would be v squared is equal to v sub x squared plus v sub y squared. Now this equation right here is just adding the vectors, while this equation would be actually adding the components of those vectors. Now as for the other relationships, well, we can construct trigonometric relationships from this triangle, and we can say, let's say cosine of theta is going to be opposite over hypotenuse, which is v of y over v. So we know that v sub y is always going to be v cosine theta. Now if we do this exact same thing with sine theta, which is cosine should be adjacent over hypotenuse. These should be switched. So sine of theta is going to be v sub y over v. Right? Sine is opposite over hypotenuse. So we get v sub y is equal to v sine theta. And if we swap this out with cosine theta, cosine is adjacent over hypotenuse, which gets us v sub x over v, or v sub x is equal to v cosine theta. So these are a couple of basic relationships you will see in two-dimensional motion. Now two-dimensional motion also comes in centripetal motion as well. So when you have an object that's moving kind of like a pendulum, if you think of the ball that hangs maybe at the end of a pendulum, you'll see that the motion is not like you're throwing a baseball, right? You'll have a pendulum right here, and the ball will swing like that, something like that. So our object's movement is going to kind of look like a semicircle with the pendulum up here. So in this case, we have two different components not considered to be x and y components, but these components are called the tangential and the centripetal acceleration. So if we were to take, let's just make a semicircle right here. If we were to take that pendulum, and if we wanted to talk about the relationship between velocity and acceleration, we know our object is speeding up and slowing down at some point over here. And we know that at the exact middle, it shouldn't be speeding up or slowing down. It should be going at a constant speed. Your acceleration should not be increasing or decreasing. So if we were to take the slope of this line, right, that would be our velocity because the graph displays position. Now if we were to centripetal acceleration, if you remember, will point towards the center. So centripetal acceleration should look something like this. And then using this relationship, we can kind of, if we were to draw another tangent line right here, this would represent your tangential acceleration, right? It's the acceleration that is tangent to that line. And you can kind of construct a triangle from these and once again come up with a similar relationship to this triangle over here. So in the next video, we're going to go over a pretty basic problem where we kind of tackle an example of two-dimensional motion, and I'll show you guys the basic equations for two-dimensional motion.